So today we're talking about rotations. We talked about reflections the first day, and we had a couple of different rules for reflection over the x-axis, the y-axis, y equals x, and y equals negative x. It's basically just rules that you had to follow. The only one that you actually had to graph was if it said reflect over like x equals 2 or y equals 1. And you had to count how far above or below it was and flip it. Okay. But the other ones had rules. Well, rotations is kind of like reflections. They have their own little rules. Okay. We did translations yesterday. And that's where we shifted left, right, up, down. That was relatively easy, right? You move it according to the way they tell you to move it. A rotation is a transformation that turns every point of a free image through a specified angle and direction about a fixed point called the center of rotation. Okay? So you have a center of rotation and you have an angle of rotation. An angle of rotation is the angle in which each piece of the free image is rotated. Okay? Like clockwise or counterclockwise through a specific degree. We normally do counterclockwise. Okay? Unless it specifies otherwise. Now, I'm going to show you here what would happen if we were to do it by hand. Okay? We're not going to do any of this by hand, but I want you to kind of just visualize what's happening. This is the notation that you use for rotation. It's a lowercase r. Reflection is an uppercase r. Rotation is a lowercase r, and then you have a parentheses, and you tell what angle you're going to rotate it, and then about what point. So this is a rotation of 100 degrees about point P. Right? And so here's the point that we're rotating about, right? And so this LMNO is our free image. Let's start out. So you pick a vertex. We'll go with L. Okay? You pick a vertex. You draw a segment from that vertex to the center of rotation. Okay? And then from there, you measure 100 degrees. Okay? Because that's what we're rotating about. So you measure 100 degrees. And then however long it was from L to P, you do a congruent segment from P to your new L prime. That's where your new location is going to be. Now this doesn't look to be the same length as the line is. Okay? So, you draw a segment from your point to the center of rotation, and you measure 100 degrees, and then you draw a congruent segment from the center of rotation to your new point. That rotates at 100 degrees. Then you go to your next vertex, and you draw a segment to the center of rotation. You measure 100 degrees again, and then you draw a congruent segment to your new point. And you do that for every vertex. And if you do that for every vertex, you create a figure that's exactly the same as your free image, but it's just been rotated 100 degrees counterclockwise. Okay? Now, like I said, we're not going to do it by hand. That, in essence, is what is happening. Because if you don't do that, you don't keep that distance the same and keep that angle the same, then your new image becomes distorted. Okay? And this does exhibit wedge in motion, which means all the line segments are the same and all the angle measures are the same. Okay? Alright, so that's kind of what happened. Alright? Now, what we're going to do is rotate on the coordinate plane. Okay? So all of our rotations will be about the origin. Alright? And they will all be counterclockwise unless it specifies otherwise. So, it's always counterclockwise unless stated otherwise. Okay? So, the first one we want to talk about is a 90-degree counterclockwise rotation about the origin. The origin is where the x and the y axis intersect. This is what it looks like. You have a lowercase r, and then you have 90, O, the letter O. And you take your x and your y, you change the sign of the y. That means change it. If it's positive, it's negative. If it's negative, it's positive. Okay? So you change the sign, and they switch places. Okay? Reflection, 90 degrees. Change the y, and they switch. Alright? For example, in yours, this accidentally got shifted down and I copied it. So on top of this first graph, we have 90 degrees counterclockwise rotation. Right above that first graph. Everybody write that. 90 degrees counterclockwise rotation right above that first graph. Okay, so here's my freaking, it's my A, right? And its ordered pair is 4, 5. Okay, so the rule is if you're going to rotate 90 degrees counterclockwise, you change the sign of the Y and they switch places. So the 5 becomes negative and they switch places. This is now my new X. Okay? And look, see how they make a right angle with each other? And they're both the same distance from the origin. Okay? Alright, so you change the coordinate of the Y, the sign of the Y, and they switch places. Now, how do you remember that? Well, I remember if it's 90 degrees counterclockwise, I always pretend that I'm in the first quadrant. Okay? I may not be, but I just pretend I'm in the first quadrant. And if I'm going to go 90 degrees counterclockwise, I have to go over the Y-axis. So that's the one that changes signs. Okay? Alright? So, if I'm 90 degrees counterclockwise, I'm going over the Y-axis. That's the one that changes signs. Okay? The next one is 180 degrees clockwise or counterclockwise. 180 degrees, clockwise or counterclockwise is the same. Okay? It puts you in the same spot. So here's your rotation, 180 degrees about the origin. You take your X and your Y and they change signs, both of them. They don't move, they just change signs. So if one's positive, one's negative, then they switch signs. Okay? When positive, they both become negative. They're both negative, they both become positive. Okay? So here is my same point, 4, 5, right? And if they switch signs, then what are they going to become? Negative 4, negative 5. And look, I drew a point, a line from A prime to A. Look how it goes through the origin, and this distance and that distance is the same. Okay, we're always going to make a straight line with each other through the origin when it does 180 degrees rotation. Now, how do I remember this one? Well, I remember this one because let's say I was in the first quadrant. Those coordinates are always both positive, right? Down here, they're both negative. So it changed signs, right? So, okay. Or if it was here and I went there, they changed signs. Yes.
So let's say it's that one was on the left.
This one was on the left. That's a negative and positive, right?
So it'd be a negative. If it was in that case, wouldn't it be a negative 5 too?
Oh, I don't want to use that. What we're going to do in just a second. But yeah, over here, this is negative positive. So if I go 180 degrees over here, it's positive and negative, right? Okay, so that's kind of how I remember that. All right. 270 counterclockwise and 90 clockwise are the same. Okay? 270 counterclockwise is like 3/4 of the way around the circle. Okay? So this right here is 270 counter. Now, so it's going to the left counterclockwise, 270 degrees. This is 90, 180, 270. Okay? This is the same as going 90 clockwise. Okay? It's the same thing. So 270 counterclockwise and 90 clockwise. Now, this is the notation. So our rotation 270 about the origin. Okay? If I do the 90 clockwise, it's a negative 90. That's telling me I'm going in the opposite direction. Okay? So these two are the same. The rules are the same. And the rule is you change the X sign and they switch places. Okay? You change the X sign and they switch places. So, if my point is 4, 5, what do I do? 5, negative 4. Okay, that's 5, negative 4. And this one, it's the opposite. When it rotated 90 degrees counterclockwise, I said you go over the y-axis. The 90 degrees clockwise goes over the x-axis. So that's what changes. Okay, that's how I remember that.
You have to switch the numbers no matter where you're on the graph.
Well, you only switch the numbers on the 270 or the 90. On the 180, they just change signs. They stay in the same spot. Okay. On the 90 counter, you change the Y and they exchange places. On the 270, you change the X and they change places. But on the 180, they just change signs. See, the X is now plus negative x. Okay. Alright? Okay, let's do a couple examples. Rotate trapezoid FGHI 90 degrees counterclockwise about the origin. Okay, so 90 degrees counterclockwise. What's the rule? Okay, so the y changes sign and it switches to the other side. So negative y x. Okay. Alright, so change the y here, negative 7. So it's going to be negative 7, positive 7. Here, you change the y, which will make it negative 2, 9. Change the y, negative 2, 3. Change the y, negative 7, 5. So now I'm going to plot those points. So negative 7, positive 7. It's right there. That's F prime. Then make sure you label your points. G prime is at negative 2, 9. H prime is at negative 2, 3. And I prime is at negative 7, 5. So name her point. And we rotated 90 degrees about the origin. Counterclockwise. I right here. The bottom left corner. Okay, now we're going to rotate 180 degrees counterclockwise. Okay, so what is the rule for that?
The signs change.
Just the signs change. Okay. Alright, so W prime becomes what?
1
negative 8, okay. X prime becomes
0,
negative 4. Y prime becomes 2, negative 1. And Z prime becomes 4, negative 2. Okay, so let's plot those. So we have 1, negative 8, which is down here. There's W prime. We have 0, 4. I was plotting the wrong one. 0, negative 4. That one right there. 2, negative 1. There's Y prime. And Z prime is 4, negative 3. So now I'm rotating that one 180 degrees. Alright. Huh? What do you mean like this?
Like the negative 8, like it goes
By 2? I don't think so.
Okay.
There might be a few, but I
When
don't
you like do it like that, it would confuse me.
I know, you have to think about it.
Yeah.
Yeah. Alright. This one is rotate 270 about the origin, counterclockwise. And that is the same as what? 90 clockwise, or negative 90, right? Okay, what's the rule? You change the sign of the X and they switch places, right? Okay, so if that's the case, then A prime is going to be what? 0, negative 9. B prime is going to be what? What's the rule? Change the X and they switch places. Change the X, what's it going to be? Negative 6, and they switch places. So it would be negative 7 and negative 6. Okay? What about C prime?
Negative 7.
Negative 7, negative 3. You change the sign of the X, becomes negative, but then they have to switch places. So this 3 becomes negative, but then 7 and negative 7 switch places.
They're both negative.
In this case, yes.
Okay.
And then what about the 0, 0?
0, 0.
Okay. So, 0, negative 9 comes down here. There's my A prime. My My B prime is at -7, -6. And C prime is at -7, -3. And B prime is at the what? Going to the next point. And I rotated 270 counterclockwise or 90 clockwise. Now, you'll have a few problems where you have to tell me what the rule is. Okay, and so in that case, you have to look at your points. Okay, and you might even want to plot what the points are. Like, if this is the way it was, I could look at this and I could say, okay, they changed places and this changed signs. So that is a 270 rotation. Okay, if I look at this one, I see also they switched places and the Y changed signs. So that's a 90-degree counterclockwise rotation. Here, they just changed numbers, right? They just changed signs. Okay, so that's 180-degree rotation. You might have one that's a reflection. So it's important to look at what is happening with the figure. So like, see this, you can tell it went around, so you know it's a rotation. But what if it was here and then it flipped? Okay, that's a possibility also. Okay, all right, last one. Now this one's a little bit tricky. First of all, we're on the third line of the directions where it says ABC, cross out the word image. I made a mistake when I did that. So cross out the word image right there in front of the ABC. Okay, it says the graph shows a rotation of 90 degrees about the origin. So this is already rotating. This is the rotation of 90 degrees about the origin. What are the coordinates of A, B, C? That means the pre-image. Okay, so we're working backwards. This is the image, and we want the pre-image, right? Okay, now let's think about it. This is after a 90-degree rotation. So my figure was here, right? And it went 90 degrees in the counterclockwise direction, yes? So if I want to go back, what is that? -90, right? Which is 270, yes? So I could use that rule. Good night. Okay, so what would that rule be? You change the
Alternate should be a Y.
You change the Y, so it's Y negative X, right? Okay, so let's say what these points are. A is located at 2, 8. B prime is located at 4, 2. And C prime is located at -2, 4. Okay? Alright, so I need the coordinates for A, B, and C. So I've got to 2, 8, that means I got to change the X and I have to switch. So it becomes what? Yes.
But if it's 90, wouldn't you change the Y, not the X?
No, listen, because we're doing it backwards. This image right here is what happened after we already rotated it. I'm wanting the original. So I've got to go back in the opposite direction for it first. Let me do the problem, and then I think once I have it done, it'll make sense, okay? Alright. Okay, so I'm going backwards, so I'm doing -90, which means I change the X and they switch. Alright, so what would this become? 8 -2. Okay. Let me do the whole problem and then I can make sense. Okay? Because the rule is, see, okay, my pre-image was originally down here, and I rotated it 90 degrees, which means I would change the Y and they would switch places. But I don't know what this is. So I've got to take my image and go back to my pre-image. So I've got to go clockwise 90, okay, which is also the same as 270. And the rule for that is you change the X and they switch places. So if I change this X, it becomes negative and they switch places, so it's 8 -2. B would be what? 2 -4. The 4 changes and it's 2 -4. And C would be what? 4, 2. Okay. Now, I'm going to graph this, and it is at 8 -2. There's A. 2 -4. There's B. And 4, 2
was black. What do you think? Do negative 2 negative?
Oh, B, B. Oh, okay. Huh? A is at 8 negative 2.
Would B be negative 2 negative?
Oh, 4, 2. I'm going the wrong direction. 4, 2 right here. Sorry. It was me graphing it, sorry. The numbers are right. I just went the wrong direction. Okay. Alright. So there is my point. Now, this, remember, is the pre-image. Okay? This right here is the pre-image. So my A is at 8 negative 2. So what I did is I went from here to here. Which the rule for that is you change the Y and they switch places. That's where they got the 2A. But I had to go backwards. Okay? So that's why I had to do that. Alright? That makes sense? Well, do you understand? Okay, you understand what a pre-image and what the image is? Okay, so a pre-image is what you start out with. The image is what you end up with, right? The black is what I ended up with. I had to come up with the red, which is a pre-image. So from red to black, it was a 90 degrees clockwise or counterclockwise rotation. And the rule for that is you change the Y and they switch, right? So if I had known these points, okay, then I would have changed the Y and they would have switched to get up here. But since I went backwards, I went from here to here, which is a 90 degrees clockwise rotation. That undoes what a counterclockwise rotation does.
But when you went to the image afterwards, it started out with X and Y.
The X and the Y.
Like the black one is X, the way you wrote it.